Think about the last time you applied for a job, or maybe took a big standardized test for school. We're surrounded by these psychological tests, right? They help make huge decisions about our lives. But have you ever just stopped and thought, how on earth do you put a number on something like creativity or leadership? It seems kind of impossible. Well, today we're going to pull back the curtain and see exactly how it's done. So, here's our game plan. First, we'll tackle the main problem, how to measure something you can't even see. Then we'll get into the 4 fundamental rules that make it all possible. After that, we'll look at how tests are actually built, how we know they're consistent, and what your score really means. And we'll wrap up with a really important question about what all this data can and can't tell us. All right, so the measurement challenge. It's easy to measure a fish. You grab a ruler, you get a number in inches or centimeters, and you're done. The rules are clear. But it is a totally different ballgame when the thing you're trying to measure is a human quality, like how conscientious someone is. The goal is the same, get a number, but getting one that's actually precise and meaningful, that's a whole lot harder. And this is a huge deal, right? If we can't get a reliable read on these psychological traits, how can we possibly make fair, objective decisions when the stakes are so high? We can't afford to just guess. So we need a system. And luckily, a pretty smart one exists. It all starts with this surprisingly simple definition. Measurement, at its heart, is just the assignment of numerals to objects or events according to rules. That's it. Whether you're measuring a fish in inches or leadership on a 10-point scale, it all comes down to the quality of your rules. Good rules, good measurement. Bad rules, you've got nothing. So what are these all-important rules? Well, in the world of measurement, there are 4 fundamental rulebooks or scales. And they're hierarchical, which just means each one builds on the one before it, adding a new layer of detail. Let's break them down. Okay, the most basic level is the nominal scale. Just think of this as putting things in boxes. The numbers are just labels. A football player with jersey number 10 isn't twice as good as a player with number 5. The numbers don't have any real value. They just tell you that one person is different from another. Next up, we've got the ordinal scale. Now, the order starts to matter. We all know that finishing first is better than second, and second is better than third. But here's what it doesn't tell us: how much better. The gap between first and second could be a fraction of a second, while the person in third might have finished a full minute later. We know the rank, but the distance between the ranks is a total mystery. This brings us to the interval scale, and this is where we finally solve that distance problem. Think about temperature. The difference between 10 and 20 degrees is exactly the same as the difference between 70 and 80 degrees. The intervals, or the spaces between the numbers, are equal. But, and this is a big but, there's no true absolute zero. 0 degrees Celsius doesn't mean there's a complete absence of heat, right? And finally, we have the ratio scale. This is the gold standard of measurement. It's got everything the others have: categories, order, equal intervals, and a big one, an absolute zero. 0 kilograms literally means no weight at all. This is what lets us say things like, this object is twice as heavy as that one. Super common for physical things, but really, really rare in psychology. Okay, so let's just quickly recap. You can see how each scale adds a new layer of information. Now, here's a really important point about psychological tests. Most of them are really at the ordinal or interval level. We often treat them like they have equal intervals even when we're not 100% sure they do, because it lets us do much more powerful math. It's kind of like a practical compromise that makes the whole system work. So, we've got our rulebook. But how do you go from these abstract scales to an actual test that a company can use to hire someone? Well, it's not just about dreaming up a few questions. It's a serious scientific process. This blueprint really shows you the whole journey. It starts with 2 basic questions. Why are we making this test? Is it for hiring? For a school? And what precisely are we trying to measure? You can't just measure leadership until you have a rock-solid definition of it. Once you've got that, you plan the whole thing out and start writing questions. And you write way more than you need, like double. Why? Because the next step, the pilot study, is like a brutal audition. You give the test to a sample group and you see which questions work and which ones don't. Only the absolute best performing items get to make the final cut. Now, creating the test is just half the battle. Now we have to ask the most important question. Is it actually any good? And in the world of measurement, good starts with being consistent. Scientists call this reliability. I mean, think about it. If your bathroom scale gave you a different weight every 5 seconds, you'd throw it out, right? Same goes for a psychological test. It all comes down to this really powerful idea from what's called classical test theory. The score you see, your observed score, is actually made of two parts. What your ability really is, the true score, plus some amount of random pesky measurement error. The whole goal of a good test is to make that error as tiny as possible. So, what is reliability? Simply put, it's about dependability. It's how free a test is from that random error we were just talking about. A reliable test is going to give you a consistent result time after time, no matter what. Without that consistency, your score is basically just random noise. But here's the thing. Reliability isn't just one single concept. There are different types, because error can creep in from different places. Test-retest checks if a test is stable over time. Parallel forms sees if two different versions of the test are basically the same. Internal consistency asks, are all the questions on this test even measuring the same thing? And interrater reliability checks if different people scoring the test would give the same score. For decades, the industry standard for checking internal consistency was a statistic called Cronbach's alpha. But, it has its limits. A big one is that it assumes every single question on the test is equally important, which isn't always true. So now, more modern methods, like the omega coefficient, are gaining ground because they're just more accurate and flexible, especially for those really complex human traits we're trying to measure. Of course, these days, almost all testing has moved online, and that has opened up a whole new can of worms for reliability. I mean, when no one's watching you take the test, the risks are pretty obvious. People can look up answers, get a friend to take it for them, or just be distracted by their cat. There's even research showing that people tend to score lower when they take these tests on a smartphone instead of a desktop. But the field is fighting back. It's kind of like a technological arms race. Things like computer adaptive testing give every single person a unique test, making cheating way harder. Companies use IP analysis to sniff out fakers and are constantly updating their questions. And sometimes, the best defense is just a good old-fashioned follow-up interview to make sure that high score is the real deal. Okay, so we've built a reliable test, you've taken it, and an email pops up with your score. But what does that number actually tell you? By itself, pretty much nothing. Imagine this is your score on a mechanical aptitude test. 48. Is that good? Is it bad? Average? You have absolutely no idea. It's just a number hanging in space. Yeah, exactly. So what? A raw score like that is totally meaningless until you compare it to something else. And this is where the idea of a norm group is absolutely critical. To give that raw score some meaning, we need context. So check out this table. Let's say your score was actually 38. On its own, whatever. But now let's compare it to a norm group, maybe all the other people who applied for the same job. Suddenly, we see that a 38 puts you at the 73rd percentile. That means you scored better than 73% of your peers. See? Now the number 38 actually means something. It tells you exactly where you stand. So, we've gone on this whole journey, from the basic challenge of measuring the invisible all the way to decoding a final score. We've seen it's a deeply scientific process that is anything but random. But that leaves us with one last, really important thought to chew on. At the end of the day, these tests are incredibly powerful tools. They give us data, they give us probabilities, they give us percentiles. What they don't give us is wisdom. A test score is just one piece of a much, much bigger puzzle. The real challenge isn't just getting the number right. It's using that number wisely, fairly, and humanely. And that's a question that science alone can't answer.